I'm Adrian Bowyer. I work at the University of Bath on the RepRap project, which is a project to make a self-replicating three-dimensional printer. Innovation means making up things that haven't been thought of before. That sounds like a dictionary definition. I'm not quite sure that I can take it much further, because it's so broad that if we start talking about individual innovations, we could go on all morning. But clearly, it's thinking new ideas. The RepRap project is a project to make a three-dimensional printer, that is to say a device that you plug into the USB port of your computer and it prints out solid three-dimensional objects. It's to make that device and to make it both open source and self-replicating. So it's a 3D printer that can print out a significant fraction of its own parts, though not all of them. And it's open source, so if you've got a RepRap printer, you just download the design off the web for free and you can print another copy of it and give that to your friend. The parts that it doesn't print for itself are all designed so that they're universally available everywhere in the world for very low cost. The fact that it copies itself. We have our oldest industry. Our oldest industry is based on objects that copy themselves. We call it farming. And once you've got things that copy themselves, you can get arbitrary complexity arbitrarily cheap. An ear of wheat is more complicated than the most complicated product of advanced engineering, and yet it's essentially free. And if you give someone an ear of wheat, in 4 years' time, they'll have fields of wheat with no extra external input. Not necessarily the death of mass production. In particular, there are classes of objects which are not going to be made using this technology anytime soon. I very much doubt that we'll be making bridges over large rivers using RepRap technology for very many years to come. So that aspect of engineering production is not going to be impinged upon. But the individual components of the bridge, things like the electrical fittings for the lighting and that sort of thing, that sort of object is amenable to manufacture using RepRap technology, and I suspect that down those paths the technology will infiltrate. The key thing about metals is not so much their strength. In fact, the metal we're working with is not particularly strong, but the fact that they conduct electricity very well. If we can print both in plastic, which of course is an electrical insulator, and an electrical conductor, then we can build three-dimensional electrical circuitry, which liberates us from the necessity of making printed circuit boards. We can embed the electronics of a device within its mechanical parts. So, for example, we could have an artificial limb which contained the electronics to drive the actuators in that limb embedded within what are effectively the artificial bones. Now, when I say electronics embedded, I should be clear that the RepRap machine makes the connections. It's not yet making the chips, which require much finer resolution than the machine currently works at. I think it'll follow the same course as things like music composition and home production of two-dimensional prints. We all run our own printing press these days, courtesy of our inkjet printer. Many of us can write music at home with a full orchestra just because that full orchestra lives inside our computers. Whether or not anyone wants to read what we've written or listen to the music we've composed is, to a certain extent, immaterial. People can do it. And, of course, the ability to make objects that are currently manufactured in conventional factories will extend that whole idea into virtually every solid thing that we have in our homes.